So we have Sharad Goel here, who is the Assistant Professor in Management Science and Engineering, as well as by courtesy in Computer Science and Sociology at Stanford University. He's also the Executive Director of the Stanford Computational Policy Lab, where he leads a team of researchers and data scientists and journalists who address policy problems using technology. Dr. Goel's primary area of research is computational social science. Computational social science is an emerging discipline that brings together computer science, statistics, and social sciences. His focus is on applying modern computational and statistical technologies to understand and improve public policy. His background, he comes to us with a background in applied mathematics from Cornell University, as well as some time at Microsoft Research. I'd also like to introduce Dave Cavander, who is a mediaX Distinguished Visiting Scholar with an extensive career in marketing science, which includes working with companies such as Best Buy, Mars, Eli Lilly, and most recently Adobe, where he was principal scientist. Currently, Dr. Cavander is working on projects such as AI-based learning cloud app for medical diagnostics and evidence-based decisions, as well as a multiplayer B2B decision-making coalition game for major retailers. Dr. Cavander has taught marketing science at UCLA and Berkeley, and he holds a number of patents in decision algorithms, and his PhD is in mathematical economics and econometrics from the University of Iowa. And I also have Dylan Arena, who is the co-founder and chief learning scientist at Kidaptive. Dylan's background is in cognitive science, philosophy, and statistics, as well as game-based learning and next-generation assessment. His degrees are all from Stanford, and they are varied. They include a BS in symbolic systems, an MA in philosophy, an MS in statistics, and a PhD in learning sciences and technology design. Kidaptive, which he founded in 2011, is a company that has created an adaptive learning platform for students with a focus on personalized, playful, and lifelong learning.
So I'll tell you a little bit about some of my work that deals with defining and designing fair algorithms. As we all know, data and algorithms are increasingly shaping our online and offline experiences, from web search results, targeted advertisements, personalized content, for example, Facebook, and personalized recommendations, for example, Netflix, among many others. And with these algorithms, there's this basic question that's emerging and getting increasing amount of attention is, are these algorithms fair? So they shape many of our experiences. Are they actually doing this in a way that we would think of as fair? Let me give you a few examples just to drive home this point. So this was, I think, taken a couple years ago. This was a search on Google. You search for 3 white teenagers. You get these pictures of 3 pretty happy white teenagers playing sports. You do the exact same search, but now instead of white, you do black. So we have 3 black teenagers, and we get this. Not so happy teenagers, and I think this strikes many people as being unfair. Whatever that means, it feels that something has gone wrong. Not necessarily that there is someone inside of Google coding this in explicitly and saying, when you search for 3 white teenagers, you get this picture of 3 happy white teenagers. When you search for 3 black teenagers, you get this set of pictures of not so happy black teenagers, but still fundamentally, it feels like something is bad about this experience. Let me give you one more example. So this is a web search for Kristen Herring. This is the stereotypically white name, and we see pretty reasonable results, just public records requests. There's nothing standing out. And now if you do the similar search for LaTanya Farrell, a stereotypically black-sounding name, the first ad that's showing up is implying that this woman has been arrested. It's asking if you want an arrest record check on this woman. In fact, she hasn't been arrested. But again, it feels like something is fundamentally amiss when you get these dramatically different types of results for a stereotypical white name and a stereotypical black name. Now, again, we don't really understand in these examples what might be might be driving it, but it feels like something is wrong. And I'm not even being super explicit about what it means to be fair, but I think that this likely resonates with many of us in the audience of saying it feels like something is amiss. Now let me give you one more example, and I'm going to go into this in more detail. This, as you might remember, is a story that came out a couple years ago. And ProPublica, this investigative news organization, did this study, and the headline pretty much says it all: machine bias. There's software used around the country to predict future criminals, and it's biased against blacks. So what are they talking about? They're talking about these risk assessment tools, these risk assessment algorithms, which are in fact used across the country. And what do? They help judges make these high-impact decisions about who to detain and who to release pre-trial. So after arrest, before trial, a judge has to make this decision whether or not someone can be safely released into the community, or whether or not they should be detained, or bail should be set at potentially a quite high amount to prevent them from, or to encourage them from committing future crimes. So traditionally what was going on is that judges would use their intuition. They would look into the defendant's eyes and say, okay, I believe you're the type of person that is going to be fine if I release you. You're the type of person that's not. There are all sorts of problems with that, as you might imagine, ranging from discrimination to inconsistency. And so there's this movement of incorporating algorithms to help judges make these types of decisions. So defendants are rated on a scale from, for example, 1 to 10, and based on their likelihood of committing a future violent act if released. And based on these scores, judges can decide what they want to do, but the algorithm is recommending a decision. So what did ProPublica do? So I should say that these tools often, when they're deployed, they often lead to lower incarceration rates, so lower pretrial detention rates. So people are, the defendants are being released more often, and often you see no corresponding increase in crime in the communities. And so in that sense, they do seem to be driving social good, which is, in fact, the purpose of these types of tools. But going back to this claim, the question is, are they fair? Or are they fundamentally biased in some way against black defendants? Okay, so what did ProPublica do? They did something very nice. They went out and they tracked 3,000 white and black defendants in Broward County, Florida, and they asked, how often is the algorithm getting these predictions right? What did they find? They found that among black defendants who did not reoffend, 31% were deemed high risk by the algorithm of committing a future violent crime. Among white defendants who did not reoffend, only about half, 15%, were deemed high risk of committing a future violent crime. So this was called the false positive rate. The false positive rate for black defendants was about twice as high as the false positive rate for white defendants. And again, having the algorithm recommend or suggest that you're high risk leads to all these potentially harmful outcomes to defendants, to their families. And so this was used to illustrate potential bias in the algorithm. So what do you think? Do you think this is biased or not? I'll ask. How many people are convinced that this feels bad, that this feels like the algorithm is biased? Biased? Okay. So I'm going to try to persuade you that, in fact, there's relatively little evidence that the algorithm is biased. And why are we going to go through this exercise? To show how complicated this is. I'm not going to make the strong claim that that the algorithm isn't biased. I'm going to make the weaker claim that this particular statistic doesn't actually suggest that the algorithm is biased. And the point is to understand that these fairness questions, while incredibly important, are also incredibly complex, and often our intuition can lead us astray. Okay, so what's going on? So I know it's late in the day, but I'm going to have you do just a little bit of algebra. I'll do it in pictures, so hopefully it won't be too painful. So here are two groups. We have our blue group and our orange group. We have our risk scores. I've written these in terms of probabilities, from 0 on the left to high risk, around 0.7, 0.9 on the right. We have these two different groups. And this is where the algorithm is going to make a decision of recommending detention, high risk, recommending release for low risk. So it has to make a decision someplace. We're just going to draw the line right here. And this is more or less what's happening in Broward County. So we have these two groups, and as one would expect, the risk distribution in these two groups is different. Any two groups are going to have different distribution of risk, so that in and of itself is not particularly surprising. Okay, now let's compute false positive rates. What's the definition of false positive rates? Among people who do not go on to reoffend? How many were rated high risk? Among people who did not go on to reoffend, how many are rated high risk? How do we do this? Well, we have to count up how many of these people don't reoffend, and we have to count up how many of them, of those, were rated high risk. How many are on the right side, divided by the entire thing restricted to the set of people who don't reoffend. So this is where the algebra comes in, but I'm just going to do it for you. 2 over 8, we can just count it up. 2 over 8. So about 8 people on this set don't reoffend, and about 2 of them are on the right-hand side. So we have a 25% false positive rate. Great. Now on the orange group, we're going to do the exact same calculation. What do we have? Well, now this whole distribution is shifted to the right. So this group is higher risk, so we have fewer people in the denominator. We have fewer people who do not reoffend. And then of those, more of them are on the right-hand side, so we about have 2.5 over 6. So we have 42% false positive rate. Okay, so just summarizing here, we just computed our false positive rates among people who don't go on to reoffend. How many were rated high risk? We have it for this group, 25%. For this group, 42%. Nothing is going on right now. We're just walking through the basic algebra. OK, so now things are going to get a little bit strange. So here we're going to take remember our orange group has a high false positive rate. And we don't like that, right? We saw this as evidence that it's bias against the orange group because they had higher false positive rates. So how can I lower the false positive rate of the orange group? Very simple solution. I'm going to go out and I'm going to arrest a lot of college protesters. Low-risk college protesters. Why? What is that going to help me with? Remember, how do I compute the false positive rate? I look at among those who don't go on to reoffend, how many are detained? Well, none of these college protesters are going to be detained because the algorithm has correctly told me, that correctly tells me that there's nothing there to be worried about. So it's not going to go into my numerator, but it is going to go into my denominator. Because all of a sudden, I have a bunch more people who did not go on to reoffend. So all I have to do to make this algorithm look fair by this standard of equalizing my error rates is go out and arrest more college protesters. So what happens here is I went from this, which all of you said was unfair. It feels unfair. And where is it unfair? Remember, going back to our ProPublic example, this corresponds to the black group. This corresponds to the white group. And we agreed that it looked unfair against the black group. Now, what did I do? I just arrested more black college protesters. And I think, again, we would think of that as unfair. But all of a sudden, it looks fair. Okay? So this is what the potential problem could be with these types of statistics. In fact, it gives us a very superficial look at what's going on. And certainly, when you see these differences in error rates, you might come at it and say, OK, maybe something is going on. We have to investigate. The same way that when we see these different types of search results, when we search for stereotypical white names and stereotypical black names, we have to investigate and try to understand what's going on. But also, we have to understand that, in fact, what we see at the surface isn't necessarily the full story. OK, so again, I don't want to make the claim that the algorithm is fair. Really, my claim is that it's a complicated story. And the next question one can ask is, are the data biased? So let me give you an example of this. What does it mean for the data to be biased? So here's a particular way in which the data could be biased. So this is a real algorithm. This is what's called measurement error. It's a real algorithm. St. George's Hospital in the UK, they developed this algorithm to sort medical school applicants. And so this seems like a great idea. There was an admissions committee. They were tired of sorting through all these applications one by one. Maybe they were worried about consistency issues. It seems like it's just more fair to have an algorithm help make these types of admissions decisions. And so they trained it on their corpus of past decisions that they made. Seems great. What could go wrong? In fact, this was a horrible idea. So what went wrong here? What are we worried about? What do you think? Because everyone's happy. Everyone's like, this is great. Now I can sit back. I don't have to spend my week on the admissions committee. Yeah?
Well, the algorithm got trained on the bias of the people that were making the decisions.
Exactly. So it was trained on the human decisions. It turns out the human decisions were biased against women and minorities. Okay? So all the algorithm did is sanitize those human decisions. And it effectively codified that discrimination. So if it's a case that we're training an algorithm based on data that we don't trust, and in particular if it's biased in a way that is, or if the data are given to us in a way that are biased, all we're doing is reproducing that bias, sometimes at scale, sometimes even exacerbating that bias. Returning to this example in the criminal justice system, what is the issue here? We have potentially the exact same issue of measurement, that the algorithm, its point is to tell us what's the likelihood this defendant will commit a new violent crime. That's fundamentally what we care about. But we don't actually observe whether an individual commits a violent crime. All we know is whether or not that was reported. And so if there's some discrepancy between who's committing the crimes and who's being arrested for committing those crimes, then we have to worry that the algorithm is not telling us the right thing. To take an extreme example, if you were to try to predict the likelihood that someone is arrested for minor drug use, well, we know that that's a poor proxy for actual use of drugs. And so one way around that in this criminal justice application is that often people will consider violent criminal activity, which we think that there might be less slippage between committing the act and being arrested for the act. But again, we don't know if that's entirely the case. Okay, so what should we do? Algorithms are very good at synthesizing information, but that's it. So they're good at synthesizing information. They can tell us how to understand that information. They can help us understand that information, but they can't tell us how to set effective or equitable policy. Those are fundamentally human decisions that we have to decide as a community. In the pretrial example, this might mean limiting money bail. It might mean, in fact, eliminating money bail. It might mean providing more robust pretrial services. The algorithm is just telling you the likelihood of some event happening. It's not even telling you whether or not that's the event that you really want to estimate at the end of the day. So there are all sorts of issues around understanding whether or not an algorithm is fair, but often this is a much more complicated question than simply looking at differences that strike us as feeling unfair. So the story here is not particularly clean. The punchline I would say is think carefully about what fairness is, but also beware of your own intuition when investigating questions of fairness. If you're interested in these types of ideas and this type of work, check out our Policy Lab webpage. So this is a relatively new effort to bring these types of engineering insights to a broad range of policy problems, including the criminal justice system, in education, in election integrity. Thanks.
Sharad's piece focused mostly on the thoughts, but because I work at a startup and nobody ever really understands what we do, I'm going to start at the beginning with just a little bit of explanation about what we do, and then I'll get to the actual thoughts. So that's the agenda. Kids today have access to lots of interesting learning relevant experiences, but those experiences are happening in multiple contexts. And those different contexts are happening on different platforms, and that means that they come up, if they're collecting data at all, they come up with these isolated data streams. And with only an isolated data stream, only seeing a sliver of data, like a little glimpse of the elephant, they can only come up with partial interpretations of learners' progress, developmental trajectories, etc. At Kidaptive, what we're trying to do is bring about a meta ecosystem, which is to say an ecosystem of ecosystems, in which kids are still learning in multiple contexts, but those multiple contexts are all contributing data across platforms to combine into a single data stream that will help us arrive at a more coherent and complete interpretation of a particular learner's trajectory. And the way to do that is to build a team that has a bunch of different skill sets. So we've got a set of people who are focused on the educational side of things, curriculum, learning, especially informal learning, psychometrics. We got a set of people who are in the whole big data, Silicon Valley distributed computing side of things, making sure that the systems that we're building are massively scalable and that they're able to do the kind of computational stuff that we need. And because we have a lot of stakeholders, we've got the learners themselves, the parents, the teachers, the tutors, the learning product developers, the ecosystem owners, and they all need kind of different lenses into what's going on. It's important to also bring to bear some user experience expertise. Okay, so we got one core product. We've got a bunch of products, but our core product is our adaptive learning platform, which we somewhat uncreatively call ALP. And what it is a cloud-based assessment and reporting platform, and it's designed to pull in data from different data streams about a learner so that we can create a universal, longitudinal, high-dimensional psychometric profile of that learner. With that profile, we can do three kinds of things. One, we can provide real-time adaptivity in integrated learning products. So the learner receives the optimal next challenge, next learning activity, next remediation, next video, next context switch, whatever. We can also give personalized insights to parents, teachers, other stakeholders in how they can support the learner's progress in the real world, in classrooms, at home, etc. And we can give rich analytics to the developers of the learning products or the owners of entire suites of learning product or learning ecosystems. The way we gather the data, it looks like this. You got kids engaging in digital context. They could be apps, video games. They could be watching videos, playing with connected toys. They could be wearable devices. You could also have situations in which learners are learning in real-world contexts, and we have some line in from a parent or a tutor or a teacher, some kind of survey, some kind of observation tool, anything that can characterize the behavior in those real-world contexts in ways that give us insight into the skills or preferences that the learner is exhibiting in those contexts. And then, of course, you got machine learning. So if a 7-year-old kid comes into the platform, we already have a set of guesses about how that 7-year-old kid might behave on the basis of similar 7-year-old kids we've seen in the past. We take all those different angles on the learner, and we use them to create a learner profile that includes proficiency estimates. Those are estimates of the learner's skills in the areas that are supported in any particular learning context, and preferences that the learner's expressed in various learning contexts, and a raw log of activities. That's the fodder for the computational modeling work that we do. We use all those, we combine them all to create what we call a mosaic of a learner, because it takes in these little individual little tiles, each of which is pretty uninformative on its own, pretty noisy. But when pulled together in the right way, they can illuminate something about the learner. Okay, so with that learner model, in addition to providing real-time adaptivity and serving learners directly, we can also give analytics to the developers of learning products to help them understand not just things like usage and engagement and retention, but things like the educational efficacy of their products, the health of particular sections of their curriculum, gaps that they might have, places where the kids might be hitting ceiling, or where there might be floor effects, where they need more easy challenges to sort of onboard learners better. We can also give reports to parents, teachers, tutors in various ways. We can give detailed activity reports about the kinds of learning that's going on, not just this many minutes doing social studies, but these kinds of concepts being explored, this kind of productive struggle, or maybe floundering. And we can give recommendations for productive conversations that parents can have with their children, or that tutors can have with the kids that they're tutoring, or with the parents of those kids to help spur intellectual, academic, cognitive, social, emotional growth. Okay, so this slide, this kind of wraps it all up. We take in information from digital contexts. We get personalized reports from the parents and teachers by asking them targeted questions. We use that to create the learner model. We use the learner model to personalize the experience in digital context, to provide personalized insights and recommendations in the physical contexts, and to provide rich analytics to the developers, the ecosystem owners. Couple of use cases, like things we're actually doing in the world. We couple million kids in the world that we're supporting right now. We've got some tutoring supports. We've got at-home and center-based tutoring contexts that we're supporting. We've got games for preschoolers made by PBS Kids that we're supporting so that those games are adaptive in real time to support the learners. We've got recommendations of videos and quizzes and little mini games and other kinds of content that kids might enjoy next. And the next application that we're working on yet is sort of high-stakes test prep. If you can figure out what the most fruitful trajectory is for the learners, they waste less of their time spinning their wheels. They spend more of their time in that sweet spot where they're grinding on questions that are appropriately challenging for them and in the areas in which they stand to gain the most ground on the test that matters so much for their future, et cetera. Okay, so that's Kidaptive. That's what we do. Now I'm going to get to the actual bit where I talk about personalization in education. I'll start with the good. There's a set of people who see primarily or exclusively the upside potential of personalization in education. And there is upside potential. You could imagine that it would be enriching to be able to look at a learner and look at the growth of that learner from the first sort of tentative strokes of a paintbrush in preschool all the way up through to professional quality execution. And you can see that whole developmental trajectory, that growth of that passion and expertise. It's compelling to think about an era of mass personalization in which everybody gets exactly what's right for them. In terms of educational equity, it would be great if you could match resources with needs so that people get exactly what they want. Everybody gets enough so that they can achieve at the levels that they sort of, in some sense, in some fundamental sense, like what Sharad was talking about, sort of is fair. In terms of research, there's the prospect of doing nuanced research at massive scale and unlocking scientific truths about learning and development, social interaction, and all that. And at the end of the rainbow is this utopian ideal of a personal tutor for every learner, the kind of thing that only princes used to have, making it available for everybody. That's the brass ring. That's what everybody's chasing after. There's another set of people who focus primarily on the bad, and there's plenty of bad. One excellent critic of personalization in education is Audrey Waters. She blogs at hackeducation.com. And in fact, this slide comes from her blog. The quote doesn't, though. The quote actually comes from the CEO of an adaptive learning startup, former CEO. And he thought it was a good idea to have people imagine this friendly robot tutor in the sky that was looking over your kids. But when I think of an artificial intelligent robot in the sky, I think of Hal from the movie 2001, A Space Odyssey. And for those of you who don't know, spoiler alert, he killed people. He was not a friendly robot tutor. But even if you had a robot tutor who could sort of anticipate the needs of a child and meet their every need with the perfect next thing, with no need for intervention or struggle on the part of the child, there's a legitimate risk that what you're doing is you're undermining the capacity of the child to develop the agency to take ownership of their own learning, to learn to make good choices about how to direct their own learning, to identify what's working for them and what isn't, etc. And in the worst case, you end up with these little sort of button pressing, click next, passive recipients of learning. With respect to educational equity, there's every likelihood that instead of increasing educational equity, these new advances will just perpetuate existing disparities, or in fact, worse than that, is exacerbate them. This thing called the Matthew effect frequently happens in educational interventions, where the most privileged end up getting disproportionate access to the hot new shiny, and then they pull further ahead from the kids who need the extra support. With respect to the idea of this sort of digital trace of learning experiences, there are people who say it's kind of dehumanizing to imagine that you could reduce a lifetime of human experiences to a succession of digital traces. And this picture is just creepy enough to kind of stick with you and make you think about, yeah, it might be a little dehumanizing. There's also the problem of a self-tightening knot. Any kind of recommendation algorithm has the prospect of leading people into believing it and thereby reinforcing itself. So, for example, if you get to college and there's some personal tutor assistant that helps you decide coursework and it says 60% of kids who look like you chose course X, and you say, okay, that sounds good. If more and more kids do that, eventually some kid will show up and it'll say 99% of kids like you chose course X. And it makes it a lot harder for that freshman to get off and go look for some other path. So an ironic but unfortunate consequence might be that this set of technologies that's intended to broaden the space of possibilities until everybody forges their own path instead just creates these ruts and is sort of channing people into different ruts, and often not in ways that we've thought out well or anticipated. Because as Sharad was pointing out, these algorithms, they're not clean and sort of Vulcan in their perfection. They're just residue of human thought and decision-making process, often messy. So that's the bad. The ugly is that neither the good nor the bad might come to bear because stuff's a bit more limited than it's easy to imagine from the outside. For one thing, there's a ton of resistance to the idea of using student data for much of anything. So there's a whole bunch of activity around legislation designed to just sort of cross everything off the list. So there's very little that you can do. There's a bunch of holes and stuff, but there is at least enough of an upswell of pressure against this that there was one infamous example a couple of years back where a $100 million nonprofit got burned to the ground by a bunch of angry parents, and they had to just give the money back and shut. So there is a lot of public resistance to even the idea of using student data for any real reason. It's also not a new idea. This is a screenshot from a product called Plato that was worked on in the 60s and 70s. And even before that, and this is another thing that I got from Audrey Waters, by the way, Hack Education. She taught me about this Pressy testing machine that was from basically like 100 years ago. And the idea was like you'd answer a multiple choice question, and if you were in learning mode, then you would just stay there until you pressed the right answer, and then you would move on and you'd then learn that thing. And if you were in testing mode, it just recorded all your wrong answers. But so people have been wanting to use machines to personalize instruction for much longer than might be apparent from all the hullabaloo that we have about it now, as if it's the new thing. With respect to academic research or scientific research more broadly, most of that work is going to be based on correlational analyses of various kinds, things that tend to hang together. And things often hang together for reasons that aren't quite clear. Sometimes they hang together for reasons that are unfathomable. So, for instance, if it's true that the number of people who drowned by falling into a pool correlates pretty highly with the number of films that Nicolas Cage was in a particular year, that doesn't necessarily unlock any scientific truths about either movies or pools. It's kind of fascinating, but it doesn't really illuminate anything. And on a more consequential note, there's a set of techniques called value-added modeling, the intended goal of which is to be able to estimate the marginal benefit or detriment that a particular teacher adds to the trajectory of a learner. And it is an interesting field of research, but it's nowhere near ready for prime time. That didn't stop a bunch of politicians from going right over the objections of the handful of people who actually understood value-added modeling and writing it into legislation. So now in dozens of states, at least for a little while, there's been legislation on the books that says you have to include some aspect of value-added modeling in teacher evaluations. And that's a bad thing. And finally, is it really true that you logged all those steps on your Fitbit? Pretty much anytime anything can be tracked, it can be gamed, it can be cheated. There are people who will do so, even in really low stakes contexts where the only reward is a little like fireworks animation at the end of the day if you reach 10,000 steps. And in anything with any higher stakes than that, there's a lot of potential for mischief. So this is Russian. It says, doverяй, no proverяй, trust but verify. And this is the part in which I'm going to try to come up with a couple of things that we should at least hang on to as we move forward to avoid the probability, or to minimize the probability that we crash into walls. The first is interpretability. When we are presenting any kind of inference that we've made, we want to be able to come up with some reason why somebody should believe it. And often that's by examination of the model and sort of understanding and interpretation of each of the elements of the model. This is a picture of a sky with some clouds. And this is how that sky with clouds looks to Google's image recognition system. It is hauntingly beautiful, and it's got really weird sort of dreamlike images in here. Like that looks kind of like a pheasant. There might be a hummingbird insect over there. There's some kind of dog-headed boy thing in the corner. But it's not interpretable. It doesn't give me any real insight into how Google decided that it would call this a sky with clouds. So on the contrary, if you have more traditional psychometric models where the individual elements of the model are relatively interpretable and understandable, then you can have conversations with people about how you arrived at the conclusions you arrived at, why you're making the inferences you're making. The second idea is falsifiability, and that term is closely associated with Karl Popper, who famously liked to point out that you could never prove that all swans were white just by finding another white swan, but you could disprove that proposition by finding a single counterexample. Similarly, with any kind of personalized algorithm that purports to be able to do anything, like boost achievement or help steer you into the right career or anything, we would want that system to be open to falsifiability. We would want to be able to subject it to some kind of test that would give us reason to believe that it is or isn't doing what it claims to be doing. And finally, integration with feedback is an important element of anything you're trying to build that isn't trivial, but especially so with something as consequential as this. It would be nice to believe, and I think people on the side of the good and on the side of the bad believe that there are people who understand personalized learning and these kinds of algorithms well enough to just, bam, go out there and make the wonderful tutor in a box for everybody, or the sort of benevolent sorting mechanism that's going to put all the ditch diggers where they belong and all the CEOs where they belong. But both of those things are pretty far from the truth because we still don't know what the hell we're doing. We're still kind of fumbling and bumbling along. And we could go the route on top where you just kind of displease everybody until finally somehow magically you arrive at the right answer. Or you could go the route on the right where you're humble with your claims and you're modest with your goals, and you try to make sure everybody's on the same page about what's feasible and what's responsible. And then you solicit a lot of feedback from the intended beneficiaries, the learners themselves, the teachers, the administrators, the parents, the tutors, that whole community, about what's working, what isn't, where they feel like you were on target with what you claimed or what you delivered, where they feel like you were off, etc. And you iterate really incrementally from there, really cautiously, so that you are less likely to make the kinds of mistakes that have disastrous consequences. That's it.
Well, thanks again for having me come back to mediaX. I had a chance to talk a couple of years ago. If you remember that, it was a little strange, but anyway. This topic has so many doorways and windows, it's a little hard to decide quite where to start. You're already onto some things which I want to really chase down here in the next few minutes. But let me just ask a quick question. How many folks in here know what Jira is? Anybody know what Jira is? Yeah? Anybody actually work day-to-day in product development? Yeah? Okay. Dylan, you're the first person I met recently that's, at least read a philosophy book. So, and by the way, I went to the bookstore here. I was looking for a book by 18th century philosopher, very famous one, but the bookstore didn't have it. And I'll go further on that for a minute. I had a chance to teach on the other side of the bay once in a while. And these are graduate students. And I asked them if they read the book. The teacher's book, I know the professor, the book's about this thick. And they all broke out laughing. He was out of the room. They all broke out laughing. He said, no, we don't read the book. We look at the, the blogs and we figure stuff out, and we don't actually read the whole book. Well, that's kind of a problem, right? And I was kind of, how did you get here? But anyway, you'll see why I want to talk about this stuff in a minute. By the way, I just retired from Adobe. I spent 5 wonderful years there. It's a great company. If you'd like to see some of the applications of a few of these topics in the world of advertising, Adobe has a product called Adobe Sensei. And advertising is very fastly going down this world of matching up all those details, right? Very similar to your education problem, right? A little more, different problem, but same sort of math, if you will. So that's an interesting question, what is it? I'll tell you my experience. I'll just jump to the end. In Silicon Valley, we call this MVP. Everybody know what MVP is? You know what MVP is? Who knows what MVP is? Somebody tell me. No, not somebody that. You're running a product team at XYZ tech company, startup or not, big company, Google, doesn't matter. MVP. Thank you. Right. Anybody, do you think that's going to work in the world that these guys just talked about? Now, what's the premise around minimum viable product? Come on. I made this thing. I didn't quite know how to do it. It's square here. Go try it. Come back, tell me if it worked. Right? He didn't tell me. He doesn't know what he wants. He doesn't quite know what we're going to do with this thing that I just made. Right? But I asked him to give me directional feedback on the product. Based on what, right? Okay. The issue that I like to talk about, and we'll get into this, I want to try and broaden your concept of personalization. And what we're really talking about is not today. We're talking about 5 years from now. What is that then? How do you feel about all these things that are helping you in your life, right? How do you design that technology? Now, I promise you the technology that's in motion today, by the way, it's moving very fast. I want to come back and talk about that. The technology is in place for the next 3 years. If I want to build a production technology and launch it at scale, it's going to take me 2 or 3 years. You just can't get it done any faster. Now, I might need an army of people to do it, and maybe I can jump it, and maybe if it's just an iteration. But if this is brand new, I'm sorry, you're looking at 2 or 3 years. So that means that whatever you're thinking about has already been baked. So if you want to talk about what does this mean in the future, you better get ahead of the curve. Because you're already too late. And I'm going to prove to you in a few minutes why you're too late. So this is part of the interesting, we're at a very interesting time. By the way, has anyone been to the Young Museum? You know where that is, right? Downtown, right? They have a big exhibit going on. It's on all the buses, or I think it's going to be. Do you know what it's called? What's it called? Yeah, it's about machines, right? It's not about the future. It's about the 1920s. Which was an enormous time of technology and industrial change. There's a great quote down there by Theodore Roosevelt. It says, this is the age of efficiency, and every machine is efficient. Wait. What did you just talk about? You just talked about efficient education, sort of, right? What did you talk about? Efficient patterning of people that may or may not do good. You didn't ask me, should you or should you not intervene in that situation? Right. Now, I'll roll the clock ahead me more, and I'll show you some slides in a minute, but what the heck. All of this stuff is here today. It works in a filtering way. So what do you think you get? Now, by the way, this is a classic market research example. If you make Colgate toothpaste, and the boss says, well, yeah, we need to cut costs 1%. OK, fine, at the factory. Find some new sources, run the optimization, take 1% out. Do that again next month. OK, do it again next year. OK, 5 years from now, you have no brand because you took away all the good things. And you didn't even notice. You couldn't even see it in your testing because they're all small incremental changes. But you slid down the hill, right? That's the technology in MVP, minimum viable product. It doesn't take you to where you're solving new problems. And that takes a different methodology. Now, so when you look at how this is all working, right, you can look at this technology and go, yeah, we're focusing on things that are simple, things that can scale globally, right? And things that are built in an MVP engineering kind of logic. They're not built in a, pick one, anybody have kids that go to Montessori school? You know what Montessori schools are, right? It's kind of messy, right? My kids, they said, well, my daughter can't read. Well, yeah, but she's been here 3-4 years, she can't read. Well, no, relax, she'll get to it. Oh, no, right? Pick any topic you want. They learn in their own sequence, which of course you know, right? But how they learn is involved in interacting with the other kids and with the constraints that they're given. Not with give me the right answer. Now I want to come back to constraints because that's the big issue here. By the way, there's 3 kinds of AI. There's what I call, for lack of a better word, efficiency. Crank a million of these out and do it in 1 second. I actually had Melissa Mayer ask me one time if I could do this product, if I could do 400 in the next 2 minutes. And I said, no, this took 6 months. She said, no, you got to understand scale. Oh, right, I hadn't thought of that, right? So you see what's going on here, right, is the technology gets boxed in. So when you look 5 years ahead, let's go back to this. I don't know, I wanted to ask Martha this because she's been around technology a long time, or at least here in the middle of it, right? I've never seen technology move this fast. This is like electricity happened everywhere all at once. We're not waiting. It's not like we got to lay pipe and put wires up and hook everything up and plug it in. Boom, right? A technology company now only hires new PhDs within the last year because the code and the technology they know is already out of date, right? So it's a very unique time. Things are going really fast, right? They're going into areas that are inherently multifunctional, that inherently value a lot of these soft factors. Now, I'll pick one. The difference in this technology is that it's very up close and personal. I'll pick one. One of the most popular social media things is cosmetics with teenage girls. That's what they talk about. How do you do this? I don't know. Well, I have no idea. But right. But you can see why it's evolving, right? And everybody's learning how to make whatever they want to make in their own way, right? So that's a very different kind of discovery world, right? It's not a predictive world. It's a world that has lots of things that are unknown, right? When in advertising, which is the world I work in, we try and hit the numbers, drive the web traffic, oh, by the way, make some money at the bottom line, and drive marginal return on incremental investment. And we can do that. We attribute that value to every touch point in every product in every retail store in the world. And we do it in real time. Tick, 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 tick. I can see, oh yeah, boom, that one paid back. Oh, that Super Bowl ad? Nope, don't do that again, right? This is all happening, right? The average person, I think, sees 14,000 seconds of media ads every day from various sources. Don't even know. You can't even count. You don't know how you're influenced, right? That's the world that we're talking about here, right? So let's go back to this. The issue with these systems is that they're not multifunctional, and they're not designed with many of the soft factors that are up close. Right? If I really want to design a cosmetic for you, maybe I need to know you're concerned about chemicals in the environment, or maybe I need to know that you like a certain color, right? I mean, the level of how close these interactions get is, I think, one of the fundamental problems, right? Because now this is really up close and personal, right? As a product or a technology, I've stepped right into your personal space. And not only that, I'm turning you around in that space in various ways that you might not like. So that, this is the part that most companies are not ready for, most brands, most technology, right? When I asked you about engineering and MVP, none of that includes this soft stuff, at least until the end, right? If at all. So that's the problem with the design engineering, right? Is we're racing with technology at all these targets, and we're going to create. And I'll give you a great example if I could. I live in Pleasanton. Anybody been to Pleasanton? Been there, right? Sort of like Mountain View. It's a pokey little town, kind of downtown, right? Okay, Pleasanton has a disease where people talk on their cell phone, and they cross the street, doesn't matter what street it is, right? And they don't look. And they expect you as a driver to stop and adjust, right? Everybody has to adjust. It's a rule. Not in Dublin, not in Livermore, not in Fremont, only in Pleasanton, right? Okay, here's the robot situation. We're right downtown. Right? You're the human driving a car. You see your mom and two kids in the stroller and the dog and the kid and the dad at Saturday farmer's market, and they walk down the street. Coming down the other way, you can see it, right, is an autonomous truck going 90 miles an hour. Now, what do you do as a person driving my little Honda Civic downtown? You see that the woman and the kids are going to get hit. What are you going to do? You're going to honk your horn? Maybe. You might just sit there and wait. Because you go, well, this happens all the time, and the truck knows what it's doing. Maybe. What would you think, right? What would you do? You might run out and grab the kids. I don't know, right? Or maybe you take your car and run into the truck so it wouldn't hit the kids. Now, you might not care about that because you go, oh, that's a machine. Right? Or maybe the machine already had this figured out and went, no, I saw him. I'm busy sending, emails to Dylan, and I'm sending charts to Karina, and oh yeah, we're optimizing, and we'll just stop just in time. Oh, but you know what? The humans didn't know that. Right? How did you know? Would you trust the truck to stop? My answer is no way. But that's the kind of technology we're dealing with. Right? I promise you, when you walk down in Pleasanton next time, you think about what technologies are watching you and what are you going to do? Now, this started with the reason I asked about philosophy, right, is I got really interested in this question. And I couldn't find good answers in the world. I'm an economist. Economics deals with justice. You mentioned fairness, which is right on, by the way. And you dig deeper and you go, oh. Now, this is a very Western point of view that I just talked about. It's very Western philosophy. I would argue I have lots of technology friends in China. How the Chinese think about this is very different. Might want to think about that. Right? But what I found out is, there's this guy, Immanuel Kant. He has a book called Moral Values. I taught a class, and I gave out the book, and I asked them to give it back to me, and they kept the book. So I was a little frustrated with their moral values. But you'll find in that book that he breaks out this stuff into sort of three parts. And one of the parts is, call it the theory or the hypotheses, maybe. Another part is, call it the physical or measurable reality. Is the earth round or flat? And the third part is all of the soft stuff and how that works or might not work. We might call that neuroscience today. Right? And that's the part, all of this soft stuff is the part that's evolving really fast today. Right? Now back to the three types of AI. The first one is efficiency, right? Make a billion. The second one is pattern recognition and prediction. Jail or no jail? Okay, cute, right? The real technology is all about cognitive learning. If you think about like service dogs that help people that are disabled, well, they have service robots, right? They have service robots that assist people that have Alzheimer's disease. These are cognitive machines. Now, there's a paper by Nick Bostrom, which hopefully is in some of the handouts. Philosophers talk about this in terms of sentience and sapience. Anybody know what those are? I didn't know before. I watched CBS and I thought sappy was how they made the TV shows, but that's not what sapience is. So let me talk about this. A couple more minutes? One? Okay. You need to think about three things. Speed. The timing in the machine is different than the timing in your brain. Right? Sentience is about the ability to to feel. I may have these backwards. I get these wrong. One is about feeling pain, and one is about wisdom. And those are the dimensions of personalization that you need to think about in the future. Because all of that stuff now is in all these layers of how much sentience, how much judgment do you want? How much do you want to recognize the emotion or the pain in this situation? And how fast do you want to do it? And by the way, the human is on a different time zone than you are, right? So you could get them educated really quick, but that may not be the best way to do it.
So our panel today is on trust and transparency and personalization. So the questions I'm going to ask are focused on that in terms of each of your works. And I think you've all addressed it in certain ways, but maybe we can start with the transparency question. There's a sense that providing users with more transparency and in some ways more ownership on how their data is being used for personalization is an important direction. And from your own perspective, and maybe we'll start this way and move back, not necessarily from your organization, but from your own perspective, and as an expert in this field, would you agree, and do you have some thoughts about how that can be done?
Yeah, I mean, I think that's exactly right, at least in certain contexts, particularly in the criminal justice context. I think many of us would not want these types of algorithms that I talked about, some black box saying you are high risk, you are low risk. And in fact, this isn't how many of these algorithms are built. So they are relatively simple, they're interpretable. So they have a set of 5 to 10 factors. Each of these factors comes with a few weights. So for example, have you been arrested previously? Have you failed to appear at court before? Things that people feel that they can latch onto and say, okay, at least I have some understanding of why I'm being categorized as high risk or low risk. But there's a trade-off with this type of interpretability. It often means less accuracy. And so this is the fundamental tension that is often in this type of work, that if we want this transparency, we're often giving something up, some loss of accuracy, and depending on the context, in the criminal justice context, I think many people are comfortable with that trade-off. In other contexts, maybe that's not the right trade-off.
Can you just elaborate just a little bit on why is there less accuracy with that?
So so if I can say that I'm going to show you 5 to 10 factors, they're going to have these relatively simple weights, and it's just essentially just a weighted checklist. That's relatively simple. And then the other extreme of that is I'm going to have hundreds of factors, and I'm going to combine them in some nonlinear way. And it's very hard for me now to tell you, why did my algorithm suggest that you are high risk or low risk? And that's the trade-off. I can't immediately tell you what's going on. I can just say, this is the output. Now, what's interesting is so I think this is a fundamental tension, that when you try to make things simpler, there's a cost. But what's interesting in our work in criminal justice is we say that we find that trade-off isn't nearly as extreme as one might imagine. And so we're finding that things that have 10 simple rule or these 10 factors, they're often about as good as things that have 20, 30 factors. So it's not like you're completely out of the ballpark in terms of accuracy. You're in roughly the same space, but there is a little bit of loss. And depending on your application, that could be important. And so in some applications, you don't really need that transparency, I think, as much as other applications, and you really prioritize the accuracy. So this is a conversation I think people haven't quite grappled with what that trade-off is. We don't even understand what that trade-off is.
So it's kind of a spectrum.
Yeah.
Dylan, what are your thoughts on that?
It came to me at two levels. My company is a B2B company, and we are dealing with partners, and we're trying to convince those partners that we can help them give meaning to their data and better support their learners and achieve the goals they have for those learners. But the partners have the right to say, how do I know that you're not just giving me gobbledygook? So at one level, the transparency is important even when we're dealing with our partners. So for instance, if we come up with personalized insights for their learners, we need to be able to justify those insights to the partners on whose behalf we're generating them. So we have technology that lets them say, okay, we're saying that this learner has been exhibiting a behavior that we call fail skip, where they're going like gangbusters until they start making a couple of mistakes. And then after a couple of mistakes, you see them skip, and just like basically they're checked out. They're like, I'm done with this. They bail out of that particular lesson and they go to something easier. That's evidence of what Carol Dweck would call a fixed mindset. And that's a really good opportunity for a tutor to sit with that kid and talk with the kid about that behavior. So that's where the second level of transparency comes in. The first level is when we say, we're serving up this insight about a fixed mindset, we should be able to go to the partner and say, we're serving up this insight because this is the set of events that we saw in the event stream. So these are the warrants for this claim that we're making. And then the transparency is also working at the second level when the tutor is talking to the child, because the tutor can say, we observed this behavior, and this behavior makes us think that maybe you think about your ability as this thing that you have a certain amount of, and then every time you fail at something, it makes you feel kind of bad, and it makes you feel sort of a threat to your self-concept, and so you totally appropriately retreat from that threat and try to do something that makes you feel better again. So that level of transparency on the part of the interface between the learner and the teacher is a way to help the learner begin to take more ownership of their own learning. It's a way to help them reflect on their own learning, see the patterns in their own learning. It's key to that kind of deliberate practice that develops real expertise, the one that focuses on and evaluates the behaviors and looks for the weaknesses, the mistakes, etc., and then works on them. So that kind of transparency can be really powerful pedagogically.
So it's kind of like an empowering transparency. What about you, Dave?
Well, if I could back up just half a second, talk about this there's at least three kinds of AI. So I talked about efficiency, call it pattern recognition and prediction. And then the third one is call it cognitive learning or more complex decisions, right? So what happens is what kind of transparency you need in each of those environments is quite different. It may be very easy to explain how you got efficiency. It may even be very easy to explain how we did the goal classification or of the states, right? Whether that's actually causal or not, right, is a whole other question, right? And there's quite a bit of work in my field about what is causal, both in medical as well as in advertising. Now, if you go back to the question of transparency and fairness, right? If you're any kind of product, you're probably going to run a TV ad. You're going to be in the stores. You're going to be on all the websites. You're going to have paid search. You're going to have people talk about you. That's social media, right? You're going to run events. You're going to do PR. If you're B2B, you probably have a sales force, right? If you have a customer, it's a retailer, right? You got a lot of stuff going on there, right? Now, the CFO, I promise you, says to the CMO, show me the marginal return on the $100 million we just gave you for the marketing budget. And I want to see it by country, by product, by touch point. So you have to make the transparency visible all the way down to the campaign activity sets, right? And the people that do this work have to include that in how they think about their work, right? Because they now make different decisions because they're getting the feedback you're talking about, right? So that's an example where the financial requirements, and call it the fairness of those relationships, has evolved to a point where, this is a huge activity set that goes on everywhere with people trying to justify, don't move my cheese. I did good. I got you the TV ad, and we got more growth, and it paid back, and I want more money next year, right? That's where transparency can work, right? The one I think that's really a challenge, and I understand a little bit about how AI works. If I'm a medical doctor, right, or a pharmaceutical company, I go through lots of clinical trials, and I do a lot of work to prove the real causality, and I may find hidden factors and lots of other things, right? Typically, that kind of causality work is not done in the world of AI. There actually is a professor over here in the economics department that has a paper on this, but that's a bigger issue, right? Like, what is really causing this, right? That's deeper questions than on the surface. This looks like what's going on, right?
It's more than transparency.
Right.
It's like,
And that's, that's where most companies go. Now, if you go to the medical system, most of these training sets grab some data and they train them based on the biases, like you said, right? But if I'm a medical doctor and I know my field, I know the clinical trials in detail. In fact, I may have participated in one, right? So I'm going to expect you to show me the clinical causality. And it better match the science that I learned, okay? Now, the problem with these systems is they're not trained on the clinical trials. So they're going to find a whole new set of patterns, and they're not going to be able to explain it to the doctor because it won't line up with anything in his, 12 years of intensive life. So yeah, I mean, this question of transparency is very important, but I think it depends on what you're trying to do.
Yeah. Transparency and context.
Yeah.
I think that, yeah. And then that's similar to the conversation last week where there was kind of one of the speakers had a slide where he talked about the context in which you really need the transparency, like where you don't care maybe when it's advertising and your LOL cats, to the other end of the spectrum where it has to do with financial decisions or medical decisions. You're going to want more transparency. So for the next question, thinking a little bit about the relationship between personalization and trust. We've been talking about, it feels like sort of moving from one end of the spectrum to the other. On one level, there's all the pros, like you said, of personalization. And then recently we've been kind of more aware of the dangers of personalization, the way that they can lead to polarization or silos or the tightening knot, like you were saying. So what do you think about how personalization can be used to increase trust? Is there a way, what are the methods? Or yeah.
Yes, again, I think that's a great question. In the criminal justice context, more personalization is more trust, in the sense that if I were to say that all young men recidivate at this rate, all older women recidivate at this rate, people feel like, well, I don't trust that. That doesn't say anything about me. But the more the decisions are tailored to me as an individual, I think the more trust people have in that. Which is actually, I think it's an interesting, it's an interesting take in this, or that's an interesting example, I think, because I've done a little bit of work in these filter bubble questions, and there I think it's somewhat the opposite, that when it's more personalized, we feel like we trust it less because now it's pushing me into these polarizing bubbles. So again, I think there is a spectrum, and it depends a lot on the context that we're asking the question in.
I think what's going on here is that when it's a personalization of a really kind of vital decision, then it builds trust. But when it's a case where you need to see the big picture, like in the case of like information or media, then you want the personalization, but you also want to be able to see that as well. Dylan, what are your thoughts about that? About how personalization can be used to build trust?
People talk about personalization in education with this lens of efficiency, right? And there is that lens. That's one flavor of personalization. But another flavor of personalization is much closer to the Montessori method. And that's much more about the personalization in the sort of idiosyncratic, learner-centered sense. And in the 20th century, in education, there were these two competing notions of what it meant to do personalization. There was like the sort of Dewey and Montessori camp, where personalization meant build an authentic relationship with an individual child, understand that particular child's needs, goals, desires, passions, struggles, etc., and support them. And that's sort of boutique. That's like a gardener working with some really fragile orchid or something like that. There's that kind of personalization. And then on the other end, there's personalization in the sort of Thorndike camp, which is all about efficiency. It's exactly that 1920s, like, yes, we can do it. We can measure the arm movements of all the factory workers, and we can measure out the number of paces to the men's restroom versus the women's restroom. And that is all about throughput. That's all about, as quickly and efficiently as possible, getting people to the right end destination. And that's the kind of efficiency that's not like tending an orchid. It's more like hydroponics and injecting the right nutrients to the different rows and getting as much yield as you can from a particular acre of harvest. I think that the dewy flavor of personalization will build trust, because trust is ultimately based on a bunch of machinery that's wired up for actual human-to-human relationships. The kinds of relationships that existed in some ancestral environment in a village of 150 or thereabouts, that was based on the fact that I know you, and I know that you know me, and I know that you have my best interests at heart. The power of a strong learner and teacher relationship to build trust, and the power of that trust to support student growth and progress is fantastic. On the other hand, if all I come to recognize is that I am being very efficiently sorted and prodded in this massive machinery towards some destination, and I can't see the destination, I just know I'm going around the turnstile and I'm going to the next thing and I'm going down a chute and I'm going up some stairs, there's no trust there at all that this fantastic system has my best interests at heart.
Best interests. The interests of the system is key. What about you, David? And after this, we'll open it to
Well, first of all, trust is a
questions.
giant word. It's $1 million word, and I'm not quite sure what that means. But I think the part about that you were just sort of, touching on is, I would argue that none of these things can be trusted today. Not a single one. And if you're trusting it, you're a fool. And if you think anybody in the next 2 or 3 years has got something you can trust, you're a fool again. Right? And the reason for that is that these harder questions, right, about what is this all about, have not been asked by any of the boards, any of the management, right, and any of the ways that people are being asked to use these technologies, right? Mm-hmm. You don't get a choice to reject your phone. I mean, the idea that you need a cell phone, right? Or they will only do certain things. So no, I don't think we should trust technology right now. I'll give you just an example. I know someone that had a cardiac stent, and it's a very big deal, right? And they've got all this 3D real-time stuff going on, and the surgeon's there, and they can put it through your, they put it through your arm, right? And then the surgeon and the software guy are having a discussion about, gee, I'd like to see this one part better. Can you change the code? Now here's a surgeon who trusts his team, right? Because they've got a patient on the table. He wants to do something he's not done before, and he's asked them to change the code. This is live. And then he says to the patient, do you want to watch? Right? I mean, the stuff that is going on in the medical field, I think medicine, if anywhere, is way ahead of every other sector in this topic.
Yeah.
Because they've had to deal with it. It's so close and personal
Yeah.
that everything that involves, doctors today only make decisions based on the numbers. Go ask them. Right? They will not make it, they'll be nice to you, but they don't make the decision based on being nice to you. They make the decision based on where are you in those norms. Exactly that, what's that curve? And where are you? Okay, you get X. Yeah. That's exactly how medicine works, right? But that's an example of where the doctor really, but see, now it matches up to, last comment quick. All these examples work best when you combine man and machine. Everybody who studies this says it's man and machine in combination. If you try and make hard, complex decisions with an efficiency machine, you will fail, right? And so machine alone fails, man alone fails, man or woman, but man and machine together will find some correct balance of how to get this right.